Of the presentation. So this is outline of the presentation. Uh, so I will cover means like what is the key motivation behind that, why we need machine learning, and few I will discuss few machine learning model, and then we will see few application of the machine learning to the agriculture. Then what are the challenges and conclusion. Uh, so if we talk about the like need of the agriculture, so we know that as like population is growing with respect to time. Currently we have total nearly 7.98 billion population, and it is expected to grow by 10 billion by to uh, 2050. So as the population increases, so we need uh, more consumption, and so because of the more consumption with that also it is find that what the current consumption per capita we have, that per capita consumption also increases. So there is a two challenges. One is per capita consumption will increase. The second is uh, total, because the population is increasing, so the total consumption will increase. So this is the projected uh, population in the billion. So based on that, like we can predict means from the current consumption, what will be the consumption in the future, like in 2050. So it is expected that by the 2050, so what the current crop we have, so the total the demand will increase nearly 60%. So this is a key challenge. So we also have to increase our like growth in that field nearly 60% to match the uh, both dimension. And also agriculture. So this is not just about the consumption. Also, like if we talk about the India, so we are agriculture rich country, and nearly 60 to 70% people they directly depend on the agriculture, and it contributes nearly 20% GDP. Uh, so India GDP. Also, uh, each year, like government make plan to like how we can do this some successful agriculture in the different fields. So they announce new package. So we believe that like without the help of the like ML machine learning model and AI involvement to achieve all the expectation from the government, that will not be sufficient. And these are the different sector that we need to enhance, we want to enhance in the agriculture sector. For example, like how we can monitor the crop condition. For example, if some problem is there with the crop, so if we can early predict, okay, what is the problem, then we can do some cure for this same. Also, if we can predict the weather and climate, then we can do some early step, we can take some early step, and then we can reduce the total loss because of the weather and climate. So these are the key area. And also, like if we have robot and that can be deployed, and it can like automate many things that we manually do. So yeah, I will discuss this thing in detail. So there are many opportunity. So if we deploy the advanced technology in the farming, for example, uh, if we have a smart tractor, maybe like you have heard about the automated car. So the property of the automated car is we don't need driver, and if we set from source to destination, so car will automatically go, and it has the proper path planning. It know the everything. So the same thing we can like inbuilt in tractor, and so that it can drive itself and it can do what we need. And also like we can use drone to monitor, and also we can use the agri robot for the maybe for the cultivation or harvesting as many more things. And maybe if someone is interested, So instead of farming, they are like doing the some dairy business and other thing. So here also, like we can deploy some advanced technology to monitor these uh, like animals and other thing. And also uh, we can get the many data, like farming data. For example, suppose that sometimes we know that okay, some crop uh, price is very high, like in some times it is very low. So people do a lot, like, so there is a lot of loss, like uh, for the farmer. So if we can use data and we can forecast okay, what will be the demand in the future, so based on that we can like grow the crop and we can get the good price. And so it will not get waste, otherwise we have not to sold this in the some cheap price. So these are the like, if we deploy the advanced technology we can handle a lot of problem. So the question is okay, how the machine learning can help in these domain. And so if somehow uh, we can tackle few problems. So I am not saying all the problem that is done by the human, the machine learning will tackle every problem. But if some machine learning is helping in the few domain and it can automate something, it can forecast something, so it will be highly helpful. So what are the key area of the machine learning where it can help uh, to like in agriculture? So we know that mostly machine learning is famous for the classification and regression task. So if we can do the regression, and that regression actually can be used to approximate the crop yielding and forecasting another thing. Also, we know that these machine learning model are very good for the classification. And so using the classification algorithm, we can actually, based on the soil or based on the climate or weather at a particular region, we can predict okay, which one was like which one will be the best crop to grow here and what we have to avoid another thing. So using this we can take a lot of decision. Also like forecasting, it will help in forecasting. And one very popular forecasting will be the weather forecasting. So earlier if we can predict okay, now there is a chance of rain, now this season there will be very less rain, and in this season there will be high rain. So based on that, actually if we know this thing earlier we can take a lot of decision. Also it decision making. So yeah. So how the machine learning, these machine learning can be used in agriculture. So as I discussed, like it can estimate the crop yielding. So now if we can estimate the crop yielding, it helps the productivity in the future. Also uh, using the ML model we can like identify different type of crop species what we need. Another thing is uh, like if suppose that some issue is there, for example, if some what it say, okay, if some issue is there with the crop, actually we can early predict and we can do the like pest control. So it will be low cost, because if somehow you can detect the problem early, it like significantly helps uh, to reduce the cost. Also like weather and this thing I discussed. uh, so it is estimated that with the help of machine learning and that AI, it can help significantly to increase the agriculture productivity. And using the automation and so here the ML means like there's a lot of place where ML can be used, like for the automation to deploy the robot, pest control, classification and forecasting other thing. So if we use all the things, so we can increase the productivity nearly 70% by 2050. And also in the first slide I discussed that by 2050 we need nearly 60% more demand compared to the what current demand we have for the agriculture product. And we know that most of the loss in the agriculture are because of the bad weather. And if we can predict, so it can further like decrease the damage nearly 25%. So it is a significant amount. Nowadays, like everyone has the mobile, and these mobile devices can be used for the lot of monitoring and other purpose. There are few application currently that is used for the crop like monitoring, and or it is used in the agriculture. For example, there is a one app called Farm Drive. So it keeps record and everything, expenses. So it helps like to get everything at a single place. And also there is a one app, it is called iCow. It is used for the like this 24/7 surveillance and the cow monitoring. And this tackles the problem like cow uh, gestation period and suggest nearest vet centers and other thing. And also there is a weed killing robot. So it these robot know that, okay, for example, if there is some crop, so these robot know that, okay, which one is the proper uh, crop plant, and which is the not the. Sorry, so there is some voice is coming from your side. Can you mute if someone is on? Okay. So these are the so these are the so these are the
Uh, Sir, unmute yourself, sir. Sir, unmute yourself, sir. Hello. Sir, unmute yourself.
okay. How? Okay.
Yeah,
Now it is
now
okay.
okay, sir.
Oh, I don't know. Yeah. Okay. So now let's talk about the machine learning model and how it can be helpful to tackle the various problem. Mostly machine learning model can be classified like broadly it can be classified to the two scenario. One is supervised machine learning, and second one is the unsupervised machine learning. And so may I know means like people are aware about the machine learning, right?
Yes, sir. Yes, sir. Little
Most of the
bit.
people. So
Yes,
yeah,
sir.
yeah. So great. So so mostly like supervised and unsupervised. So if we talk about the supervised, so what we have in the data, we have label data. So we have data and also we have label. We train a model. Once we get the trained model, then we have the test data, and using this test data, and this test data is different from this what the data are there in the training. And using the test data, actually we can predict the label. So this is the uh, key thing in the supervised machine learning approach. And if I talk about the major supervised machine learning model, so here there is a classification model and regression model. And in the classification model, so in the traditional machine learning, it is k nearest neighbor SVM. Logistic regression, it is used for the binary classification, decision tree, naive bayes. And in the regression too, there is a lot of regression model, for example linear regression and polynomial regression, Lasso and ridge. So these are the standard model that traditionally used in machine learning for the supervised classification and regression both. uh, Also recently, so the problem with this approach is so they need pre-processed data to solve that problem. Recent model, for example the deep learning model, so they extract the feature automatically and solve the problem. So beyond that, there is a like deep learning model, for example convolution neural network, transformer architecture, and these are very popular nowadays. And also there is a unsupervised learning, where in unsupervised learning we have the data and we don't know the label. So if we have only the data and label are not there, so what we can do? So mostly we can do some, uh, we can learn some underlying structure. We can find out the, okay, what are the similar kind of data, and what are the pattern in the data. So these things can be easily identified using the unsupervised learning. However, we don't know the label, so we cannot do the classification. So clustering is one very popular approach for the unsupervised learning, and there are many clustering algorithms. For example, DBS scan, k-mean, hierarchical clustering, and Gaussian mixture model. So many clustering algorithms are there based on the use case. Actually, we use these algorithm. For example, if data are linearly separable, so k-means clustering shows very good result. And here, but we have to know, like earlier, how many classes, yeah, how many cluster, not classes, how many cluster we need. While in the hierarchical clustering, actually we don't know how many cluster we need. So here, based on the some distance threshold, we do the clustering from top to bottom. One popular approach is Gaussian mixture model, where it can do the nonlinear. If data is non-linearly separable, so the Gaussian mixture model can be applied to get the cluster. However, this k means, and it will not be able to separate the non-linear data. So this is a one key difference. Like in supervised machine learning, we have data and label, and mostly we can predict after like training, we can predict the label. However, in the unsupervised, we have just data, and using the data, we can find out the structure and other things. So if like clustering is one structure, then we can do the like similar kind of pattern we can match, and they can get, like they can be together. So once we have machine learning model, so our next step is means how good or bad these model are. So to evaluate this thing, so there are many criteria. And so one thing is, like, we know that if model is not properly, means what the model need, for example, to fit, like to fit in the data, model need a proper complexity. If the complexity is not like properly what we need, so either it will be higher, either it will be lower. So if we have very high complexity, so the mostly model will get overfitted. And if we have very low complexity, so model will get underfit. And also there is a bias variance trade-off, and we need, so the thing is, what we need actually high bias, low variance, or low bias, high variance, and what we need. So the thing is, uh, so there will be four scenario, like low variance, low bias, high variance, low bias, and high variance, high bias, and low variance, high bias. So there will be four scenario, and this four scenario, the optimal will be where we have like total error minimal. So here total error means like bias plus variance. Here if you see, the total error equal to bias plus variance and some irreducible error. So if we ignore the irreducible error, so we have bias error plus variance error. So total error will be bias plus variance. And now if we have very low complexity, for example, straight line, we want to fit this into the data, then in this case model has very low variance, but it has very high bias. And also if there is a like high complexity in the data, so the high complexity in the model, so the model will get fit into the data. So in this scenario, actually, bias is very low, but the variance will be very high. So the summation is like bias square plus variance, so the summation total error will be high. So we need a scenario where we have the minimal total error. So we need some complexity in between. So here it has very low complexity, here it has very high complexity, and we need some complexity in between. So here it is showing the perfect model fit. And also, like, there is a, if there is a problem of the, so mostly actually we don't know the scenario of So it is very high likely that model will get overfit because generally we use very complex model and data are very simple. So overfitting is more uh, prominent problem compared to the underfitting. So our most of the effort we put to get the uh, to get overcome this overfitting scenario, and to solve this problem there are many approach that is used. For example, so there is a ridge regression, lasso. So ridge regression is just a L2 regularization, lasso is L1 regularization. Also recently there are many approach. For example, in the neural network there is a popular approach to reduce the overfitting is dropout. And so these are the thing that we can use. And other thing, if I talk about the like regression tree and random forest to here, like height of the tree and other thing, it can be fine tuned to get the proper regularized model. So mostly let's discuss like how this regression and ridge regression and also helps to get like proper model and it reduce the overfitting. So what we do actually, so we have one loss function that we want to minimize. Loss function means like if we want to fit this curve to the data, and so now the difference between this like this point to this and this point to this, in this way like we compute the loss. So we have a standard loss function. With the loss function we also add a coefficient term, and this the responsibility of the coefficient is to reduce the so to increase the smoothness in the curve. For example, so if I talk about this, so here this curve are very like non-smooth, and this is a scenario of overfitting. Then in this case, like if you find out this curve, for example, this is some maybe like 10-degree polynomial. So the value of the like polynomial coefficient will be very high, and here the value of polynomial coefficient will be very low. So we need polynomial coefficient should be like in middle, yeah, in between some high and low value. So if somehow we can regularize this polynomial coefficient and such that it has the minimum value. Now if it has minimum value and also it is reducing this my it is solving my objective, then always it will be smooth. For example, like here, if had the polynomial coefficient value maybe like 10, 20, 100 something, and you minimize this thing, so the during minimization it will get the value maybe zero point 0.1, 0.7, 0.9. So it has the low value, so the overall loss will be low, and now we will get the smooth curve. So in this way like this regularization helps. And also there is a L1 regularization that helps to get the sparsity in the data. So this sparsity actually it suppress many dimension in the data, and this helps to reduce the overfitting. Also because we are minimizing, so it also helps to reduce the that square loss coefficient. So if I discuss about the like few supervised learning model, one traditional model is k nearest neighbor, and it is purely non-parametric algorithm. Here we don't have any parameter, only we have the set of data point, and based on this set of data point actually we take decision. So we have some distance metric, and using this distance metric and this distance metric it is generic, it can be many kind of distance metric. So once we have set up data point, maybe like we have 1,000 data point, and during inference we get some new data point. So new data point actually we measure the k nearest data point, and based on that actually we take the decision. And this distance metric can be defined as actually if we take c equal to 1, so it is just Manhattan distance, and if we take c equal to 2, it is Euclidean distance. So Euclidean distance is very popular. Also cosine similarity and other, yeah, cosine distance other are very popular. So the it's like so the problem with the maybe like the problem with the Euclidean distance is it depends on the magnitude, while the cosine, so once the model depends uh, on the magnitude value, so it may have like scalability issue, because in this space, if some value is very high and some value is very low, so if it is not on the proper scale, so it is very difficult to set the like threshold value, or very difficult to set the value of k in the k nearest neighbor. So cosine similarity, cosine distance is very popular, where it does not consider the magnitude, just consider the direction. So what we do in the k nearest neighbor during inference, suppose that this is data point, I want to measure the class of this data point. So we take k nearest neighbor from this data point, and here 3 point are from the maybe class 1, and these 2 point are class 2. So we assume that okay, this data is from the class this one, class 1. So this is very simple, and this doesn't have any parameter. But issue with this model is we have to measure the distance with everyone. Suppose that if we have the millions of data, then for any inference you have to take this data and compute the distance with the millions of parameter. So there are many faster algorithm, like we can do the some kd tree and other things, so speed up, so that we can use to speed up the algorithm. And second popular approach is svm, the support vector machine. It is again very popular, and it gives the max margin classifier. Suppose that we have two class of data, then this model tries to learn a hyperplane. That hyperplane tries to separate these two classes with the max margin. So max margin is here, max margin is key here. I will discuss okay how like they do. Uh, Now this svm can be the linear svm and non-linear svm, and so actually this hyperplane always it will be linear, but there is a trick to make this uh, from the non-linear, this to solve this non-linear problem. So what actually people do uh, to learn this hyperplane, actually uh, we solve a equation so that actually find out two plane that is on the uh, closest point. So closest point means, so if there is a boundary, and if there is a boundary, so find out the two hyperplane that is the on the decision boundary of this data set, and find out the second that is decision boundary on the second data set. And between these two, so there is a now from this boundary and this boundary, so it has the maximal like separability, and in between, so there will be max margin hyperplane. So to solve this equation, actually we have a like complex equation, and if we solve that and we get this data point, so it find out this data point automatically, and we need a svm solver for the same. And this is very popular algorithm, and it is max margin. So if suppose that some data is noisy, and it is from, it is not here but it is coming here or here, so still it is robust and shows very good result. But the thing is, always is it is like now look like this hyperplane is linear, because it cannot have any curve kind of shape. So how you can do the nonlinear classification to solve this actually nonlinear classification problem using the svm? We use the kernel trick. So in the kernel, actually we increase the data dimension. Suppose that my this data is of dimension k. Suppose that I am in the two dimensional space. So in the two dimensional space, none if you draw any hyperplane, and none of the hyperplane can separate these two data. But if I suppose that this is xy, also if I add a z axis, and in the z axis here red point has maybe like value 0, and this has in the z axis this has the value 1. So now between these two we can easily draw a hyperplane so that we can easily classify. So we use the some kernel trick where we increase the dimension of this uh, space, and we increase the dimension such that it can get classify using the just a linear hyperplane. So this is a way to classify the nonlinear data. These kind of approach. So problem with these kind of approach is actually it requires the feature extraction. And for example, if I want to classify this data from this data between these two, so I need different kind of feature. Okay, what is the color, shape, type, this, that. So, and this feature also it can be extracted using the multiple algorithm. So we need to extract the feature from this data. Then once we extracted the feature, we can fit to the SVM or k nearest neighbor or some like boosting, bagging, or some any classification method. And now suppose that I want to classify this with this. So the feature what we require here, that may not be sufficient if I want to classify between these and these. So here maybe we need a different discriminative feature compared to this pair. So how you will extract the feature, and that is a key challenge. And priorly we don't know, and there are algorithms so they extract feature, but the problem with this the feature extraction method is these feature extraction method is not discriminative because they just extract a global feature, and they don't know what kind of task and for what task we are extracting the feature. So if we have a method that can learn feature itself, so that will be a like key point, and that feature will be very useful, and it has like it will have the very discriminative uh, cluster or something. So to solve this problem, actually the deep learning method came, and there is a lot of deep learning architecture tools in the recent literature. So the first model they proposed in 1988, that is LeanET. So it has very small architecture. So very small size image, like it is grayscale image 32 cross 32 in 7 layer, and here two convolution layer, and then like four classification layer are there. And so this is proposed that then recently, like 10 year ago, the people saw that okay, means like if I scale this model for the higher and train in the GPU and other things, so we can get very good result. So people design a new architecture that is called the AlexNet. It has much higher parameter, and it is much deeper. It contains the like five convolution layer and three fully connected layer. It has nearly 60 million parameter. And now the problem is to train this method. Actually, small data set are not sufficient. So we need huge amount of training data to train this model. And once we train this model from this, like this is input image and this is the output, and once we train this image end to end, so model learns the feature itself, also it do the classification. And later like people did the extension in the same this convolution architecture, and that is VGGNet. It is much deeper layer, and it contains nearly 140 million parameter. It is 16 layer deeper. So the problem people find that okay, if we increase the layer size, so the model performance was getting increased. But when people applied the instead of 16 layer, they increased this further, then they got the 19 layer VGGNet. That 19 layer VGGNet has the lower parameter compared to the lower, so it has higher parameter compared to 16 layer, but it has a lower performance or lower accuracy compared to the 16 layer. So it means that you blindly cannot increase the number of layer, and if you will increase, the model will suffer the performance drop, so no need to increase. So to solve this problem, next paper came ResNet. So it solves this problem, and it says that okay, if you go if you use the residual connection, and if you go any number of layer, so the model performance will not degrade. So to solve the problem, so actually they propose the residual connection. What the residual connection do? So initially, suppose that this is a layer, and the model that this input is passing from this layer, and we get a output fx. So this is x, and this is function f, and we got the output fx. So this was there in the VGG. Now they said okay, with the fx, if I add this the same input what we got here as a x, also we add this. So what happens? Suppose that this layer is not working, but before this, suppose that there is a tens of hundreds of layer before that. So suppose that this layer is not working, but the previous layer is working. The same x, at least this fx does not have the good extracted data, but that this x has the same data, and that we transfer to the output. And in this way, they make a skip connection. Now it helps to train the model for any deeper layer. So this is their architecture. So they add a skip connection after a few like set of layers. So they call this block. So now they train like 152 layer network, still it shows very good result. And now this ResNet architecture, it shows state of art result, and it outperforms the this is the first model which outperforms the image recognition model, and it beats the human. So that is very good achievement in this field. So all thing because they have very good feature extraction capability. So now the question is, okay, if we do the end-to-end training, what the deep learning model actually learn? So they observe that, okay, if you go to the initial layer, so it has like it learns something like this stride. Stride means like it is some kind of gradient or something. Then layer 2, it start learning something like shape and pattern information. And if you go to the uh, deeper layer, so layer 3, layer 4, and layer 5, so if you go to the deeper layer, now it start focusing to the key discriminative part, so that it can easily classify. For example, like if you see here, so this what it is learning here, maybe it is very close to what it is learning here, and also maybe it is what it is learning here. But if you go here, so now the what it is learning here, that is very discriminative, and it focus on the key part. For example, if I take this dog, so it focus on the ear, mouth, and other thing. And if so there is a some this bird something, so it start focusing on the eye and other thing. So now it is very good, it has very good learning capability for the uh, if we have sufficiently large data. And here we don't need any feature extraction. Model learns the feature itself and do the classification. So this is one thing. Yeah. So these were the introduction for the ML. Now let's see means how these ML model can be used to solve this what the challenges we have in the agriculture domain. So one this is one paper though. So it what it do, it classify the uh, grab leaps using the nearest neighbor, k nearest neighbor and SVM classifier. And any, so instead of this k nearest neighbor and SVM, any model, any classifier can be used. I am taking this thing because it is from this paper. So now instead of grape leaves, you can take any kind of crop and you can do the classification. So here the objective is, okay, let's now see how we can collect the data. So what they do, and so they collected healthy images and unhealthy image of the leaf. And once they have this training data, so now like this is my healthy image has a class 1, this is unhealthy has the class 2. So once we have like these set of data, we can extract the feature and feature extraction. So actually in this paper they are using the some co-occurrence matrix for the feature extraction. But if you use the feature extraction using the deep learning model what I discussed earlier, like ResNet and VGGNet, so it will give you much better feature. And once you have the feature, actually we can apply the k nearest near r SVM. And also if you don't want to apply the k nearest near r SVM, so this deep learning model itself will do the classification also. So let's discuss about the just how the nearest neighbor and SVM can be used. So now they collected the different images, healthy and unhealthy, and extracted the feature, and that extracted feature are passed to the SVM and k nearest neighbor. So total now, for the feature extraction, so they extracted 4 kind of texture and 18 kind of color, and that is used for the classification. Now if you see that SVM has 90% accuracy for the classifying. Classification means like there is only two class, healthy and unhealthy. So and while the Canon has the better result. Now this is used only for the grape leaves classification, but this same thing can be used for any fruit classification, yeah, leaf classification. It can be any kind of leaf. Just you have to create the data set. And here they are using the binary because they have only two class, but any number of classes can be there. So this is one application of the ML how it can be used to get the like. So the thing is like Here in the agriculture field, actually you can mount the, so no need to do the manual monitoring. You can mount the camera, and maybe like it is sending daily one images or two images, and so that images actually can be used to easily detect without going to the field. So the conclusion of this is now, so this will help to get the automation of this disease classification, and once we know the disease, we can do the early some preventive decision, and that will help to increase the crop yield and other thing. Also, uh, in the future, like system can be trained to identify the disease present in the grape. So here just we so actually using this leaf, we just tell okay it is healthy or unhealthy. Also, we can train a model where by just seeing we can tell okay what are the disease uh, from, and that is what are the disease from which this plant is suffering. So maybe so it is it so this will help because so different kind of disease may have the different kind of effect in the plant, different kind of effect on the this leaf, and that model can easily identify. And once we identify and we can early identify, then we can take a like large preventive step, and also it will reduce the my significant cost. Yeah, so also like we can mount the camera and no need to go, and we can do the automation. So this is another application where so we do the crop and fertilizer recommendation system based on the soil classification. So the idea is like if so there is a different kind of soil, right? And each soil has the different capability to grow the crop. For example, if like every crop requires some particular kind of soil to get the good growth. So if we can classify okay what kind of soil is there, and based on that actually if we recommend the crop, so we can get the good outcome. So for example, this is the data collected from this Chikmagaluru district, and here so the people taken like 1500 soil sample, 70% are used training and 30% are used in the testing. So soil has the different kind of attribute like nitrogen, potassium, calcium, magnesium, lime, and these moisturizer and other thing. Now we know that, so based on that actually they define the class. Okay, so if it, so now this attributes for every soil, these attribute exist, and these attribute based on the presence of uh, some like in the some soil this magnesium is high, in the some soil nitrogen is high. So based on that actually they divided the whole soil into the four classes, so class 0, 1, 2, 3. So now they are saying if data is from the class 0, so it is low fertile. Now these kind of crop you can grow here. Now if it is moderately fertile, then these kind of crop you can grow. And for high fertility, uh, that for high fertile crop, you can grow these kind of, because it requires like huge uh, these attributes are huge in huge amount of like calcium, magnesium, also nitrogen, potassium, what. So now just idea is just take the soil and do the classification, and using the classification actually we can easily recommend what kind of crop we can grow here. So for example, like if we have like Ca value, magnesium value this, and the this cage some potassium value this, then it is from the class 1. Now if we have like magnesium value here increased and calcium value increased, cage also increased, so we can like it is classified to the second class. Now we can grow actually the second kind of uh, this crop set list. So they collected the data and trained the SVM model, and they got this much accuracy from this total data. This one is like 845 is classified correctly, and these are incorrectly total testing from the total testing data. Also, k-nearest neighbor are used to get the classification, but it shows nearly 72% accuracy, while the SVM get nearly like 77, 78% accuracy. So here we can say that like SVM get the better result compared to the k-nearest neighbor, while in the previous approach we observed that the k-nearest neighbor is getting the better result compared to the SVM. So based on our classification, actually we can recommend the crop, and this will helps the farmer to grow the best suited crop, and that is adaptable to their soil. Also, the model can improve with the more hyperparameter tuning with the help of increased accuracy, and this model will help more to the farmer. So these are the second case study, and also this can be further like if we collect more data and we train some bigger model to using the deep learning, so we can get the better result. So this is just so that okay means what are the problem and how we can create the data and how the ML model can be helpful to solve the some problem that we are facing in the agriculture, because the mostly farmer they don't know okay data this my land it has the soil from the class 0, 1, 2, 3, and they don't know what they have to grow. So this model will significantly help to like take the decision. And also like let's check one more case study where ML model is used to like sugarcane crop yield estimation using the k-nearest neighbor. So here like simple model are used, but any deep learning model can be used. Again the same thing, because just I want to show here, and I have this result, so we can easily get some idea. So first thing like we need to source the data, then in the data we have the like we have different attribute. For example, okay, what is the rainfall to that particular region, what is the pH value, organic carbon, and like area, and what is the attribute present in this soil. And now we want to predict the yield. So based on this we can train the model, and this data is collected from the Telangana, and it is like from a long period of time, so this data is more reliable. Now once you like we have the data, and suppose that once we have net data and we have the corresponding label, because these are the supervised classification problem, we have data and we know that with this data okay how much yield we have. So we have set up data मतलब data 1, data 2, data 3, and also for this data 1, yield 2, yield 3. So if I apply the k nearest neighbor, so what we can do, just apply the like k equal to 2, 3, 4, 5, and see where we are getting the maximum result on the uh, test data. So if we have k equal to 5, we have nearly 73% correct yield prediction. So this yield prediction can be used for the forecasting. So and this forecasting will help to make you decision. Yeah. So the accurate yield prediction across the different area can help the farmer to get the better profit and crop. Also, in future, it can make the prediction using the different algorithm. For example, I discuss again like the using the deep learning model and transformer architecture. So this is just some few simple example where we can use ML model. And same thing actually it is used. For example, it is used for the sugar canes, and same thing you can use for the different kind of crop. So based on the soil, you can predict okay how much uh, like in per square area how much crop you will get. So that will help you to plan your like things early. This is one final case study where multivariate weather anomaly detection using the some clustering algorithm. So all the three study what I discussed, it was mostly supervised learning problem. This is unsupervised learning problem where the idea is actually for in any particular region we have a particular kind of weather, and sometimes and this weather got change or it is very much changed. So on that year actually there is a lot of issue, maybe like flood, maybe like there is a drought and something. So based on the like whether we can take some decision. Now the thing is, when we know okay this is beyond the normal weather and till which region it is normal and on which region it is like abnormal, and that will be significantly harmful for us. So for this actually there is a data they collected. It is collected from the like this Semarang city, Indonesia. It has the 8 attribute and it is daily weather data. So in that, so they have the minimum temperature, maximum temperature, average temperature, humidity, and sun exposure time, wind speed, and these average wind speed. On that, so we can use actually some clustering algorithm, and using the clustering algorithm, we can see okay. So this is my actually when I do the clustering, this is my one class. If I say like in another way, this is my some. I have only one class because I have normal data, and using the normal data, I learn the clustering, and I make a decision boundary. And now once I have the decision boundary, I have something new data, and if that new data is my beyond the threshold, so I will say okay these data are abnormal, and here like we it is manageable. And now as we grow as we move from this like center of this position, so the things will get worsen, but till this boundary it will be manageable. So now this data will be outlier and this will be like significantly harmful scenario. And so this can be used in an unsupervised manner, and here we don't need any label data. Also like PCA and any dimensional reduction technique can be useful further to reduce the dimension, but here like we have only 8 dimensions, so maybe we don't require too much reduction. But if you want to do the analysis and display and some analysis, then the PCA may be helpful. So yeah, that's all from my side. Now let's conclude. So okay, so this is final conclusion. The result showed here in the anomalous weather is characterized by the high humidity or low temperature. So for example, uh, now they observe that like if they have very high humidity or some low temperature, then these are the scenarios. So actually now using this data you can do the some analysis, and in the analysis they found that okay if this is the scenario, then mostly it becomes the outlier. And also the experimental result had demonstrated the DB scan is capable of identifying the particular data, and that data is deviating from the my normal data. Okay, so the PC and DB scan can be utilized. So yeah, so this is the final conclusion, and this is the conclusion for the this last model, and now this is the conclusion for the whole slide. No, this is challenges. Okay, I have one more slide, I think. Okay, yeah. So now what the current challenges actually we face? One thing is availability of the data. So actually we discussed that every place we need data, and data collection is difficult. And for the data collection we need the expert knowledge, because the farmer and the normal people who don't know the like details, though they cannot collect the data. And also we need annotation, so that annotation also it can be done by the expert people only. So the data collection is challenging, and so many other thing actually, for example, satellite, drone, and tractor sensor, and these things are used for the data collection. But for example, so the satellite captures a lot of data, and that data can be used for the analysis. another thing. And for example, if robot is moving in the field and that is collecting a lot of data, and that data can be used for the analysis. And quality of data is again another challenge, because I mentioned that. So for the data collection and annotation, we need the expert knowledge, and to get the like agriculture expert and these things in many like maybe like some remote area, it is very difficult to get the expert and these things. So quality of data is again a challenge. And also there is a lot of policies and regulations that is by the government or by the company, how the mi like ai can be used, how much not you can use, like you cannot put camera everywhere. So these are the regulation and challenges. So this thing also we have to take care. And social awareness is again other problem, because most of the people they are not aware of these all the thing, so how they can use. And how this, if you have like maybe you built some model, so you have to socially aware, okay, build a model that can do the like disease prediction in the crop, and then you can do the some care about that. So to get the aware the people with these model or these algorithm, it is a difficult task. So yeah, let's finally conclude. So as we can see that in the first algorithm, Canon shows the best result, while in the second algorithm, uh, SVM shows the better result. So no algorithm is best. It based on the situation and based on the like our use case. Some algorithm perform well, and some other perform in the some other scenario. Some other perform well. Also, like choosing the technique dependencies like pattern, type of data, and experience of the analyst. Using model as a pipeline can save a lot of time of the analysis and give the fast solution to the farmer. There is wide scope of application of ML in agriculture, especially in the plant disease classification, soil and crop classification, and other field. And automation, surely it can help reduce the biotic and abiotic stress. Biotic, I think the biotic is mean like some disease, yes, because of the some insect, what the problem we are facing. Abiotic means like it is because of the like weather, temperature, and other stress what the field is getting because of this scenario. So automation it can help to reduce this thing. Yeah, these are the reference. So yeah, my uh, talk concludes here. So if you have any question, please let me know.
Good evening, sir.
Good evening.
Sir, I wanted to know that what amount of accuracy is expected or comparable in such models, and when we are
So
taking data. Uh, yes, sir.
yeah. So actually there is no proper definition. So for example, suppose that if something is there and we are getting 80% accuracy, so it is better what if we are not getting anything. Now the accuracy depends on the actually use case. For example, like if you are doing some cure to the human, so in that case you need very high accuracy. For example, if you are doing giving some medicine to the doctor, not if you, like doctor is giving some medicine to you and it is curing some maybe like cancer or something. So on that scenario we need very high accuracy, but in this scenario actually now if we are doing better than average, so it is okay for us. So there is no proper definition of the accuracy what we need, but yeah, higher is better always.
Okay, sir. The second one is when we are taking input data and
Hmm.
labels. You said that you have used the Telangana data set. So, what are the input parameters like soil? Which parameters are taken, and what is the exact label or what are the input parameters, sir? That I wanted
Yeah,
to
yeah,
know, and from
yeah,
where
yeah.
you got it.
Let me tell. Uh, which one? This one, right? Yeah. So these are the actually attribute. So now I have feature 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are the my feature, and for the any soil I will get this feature. I will calculate this feature, like what is the rainfall for this region, what is the pH value or organic carbon, what is the area, and what are these minerals in the soil. So these are the parameters that are used uh, in the data. And so this parameter once you have, and so these are annotated by the expert. So actually they have the historical data. So if like suppose that maybe they have like 10-ton crop in the some with the some parameter, then again have 15-ton crop in the some parameter. In this way data are collected, and this is some public data. I think you can refer to the paper. And so which one here, some paper I refer to this, no? Okay, this one, Kumar et al. So you can refer to this paper in the reference, and you will get more detail about the data. And so yeah, on high level, yeah, so these are the data, and so based on the historical, so we have the label like
Sir, can you share the PPT?
yeah, I will share the PPT.
Thank you, sir. Sir, very nice session. Thank you very much.
Hello, sir.
Yeah,
Good evening.
good evening.
Ah, sir, uh, RGB, I have, now I'm doing the research in the disease identification, leaf disease
Mm-hmm.
identification.
Mm-hmm.
But I have a question. Uh, RGB or IR, which type of image can easily to identify from the disease, easily identify the disease from the images, sir?
So
How to
RGB
plan
and
two images, two type of images. One is infrared images, another one is RGB images.
okay. So actually there is no proper definition. Sometimes infrared image also will help, and sometimes RGB. So maybe so in infrared images, it is nearly mostly it is gray scale, right? It has single channel, right?
Plus color image.
Infrared color image. So how many
Yeah,
channel we
yeah,
have
yeah.
in the, how many channel we have in the single image?
I can't understand, sir.
So like RGB has the three channel, na? Red, blue,
Yeah,
green,
yeah, yeah.
right?
Yes, sir, sir. Yes, sir.
In the infrared, how many channel you have?
So infrared means
So
I
okay, so
don't
if
know
you are
the
missing this
proper.
information, okay, no
Yeah,
problem.
yeah. I have
So
a
the thing is,
doubt,
yeah,
sir.
yeah. So thing is, mostly people get better result when they have more richer information. So sometimes something are not captured in the RGB image, and infrared it is like something temperature sensor kind of thing.
Yes, sir.
And based on the some changes in the leaf pattern or something, so that sensor will capture that different kind of information. So if you use both, so always you will get better result. So what I will suggest, like you if you use the two encoder, one is for the RGB or one is for the infrared, and you get the two encoded value, and like now the both embedding if you use for the classification, you will get better result.
Okay, sir. Thank you. Thank you, sir.
Still any queries are there, please?
Any other?
Any other questions? Yeah, sir, thank you, sir. As of now, no questions are there.
Okay, thank you.
We,
I will share this slide to you, and
sure,
you share to everyone, right?
sure, sir, sure,
Okay.
sir. Thank you, sir. Thank you very much. Thanks for
Thank you.
such a wonderful session. And you gave a lecture on what are the machine learning models and how you correlate to that, what are smart farming. And excellent, sir. Thank you, sir. Thank you very much.
Thank you. Thank you, everyone.
Thanks. So, dear all, one poll it is there. So, dear all, please, one poll it is there. All of you, please go through that poll.
Sir, it has disappeared, sir.
Where it is, sir?
It
Yes.
is disappeared, sir, now.
Yes, it is, sir. I'm relaunching, sir. Yes, sir. Sir, please check it out now.
Right,
I
sir.
think it is visible now, sir. Please. Is it okay, sir, now?
Yes, sir. Yes, sir.
Thank you, sir. Sir, poll automatically it will come, sir. There is no separate link.
Can you release, sir? Has it submitted?
Sir, next session is there 7:30, sir. Exact.
Okay.
One more session is there 7:30 to 9.
Okay. Okay.
So, all right.
Uh, Before going ahead, is my screen is visible to everyone?
Yes, it's
Yes.
visible, sir.
Yeah, thanks a lot. Uh, so before going ahead, I just want to know like what is the participant expectation? Maybe one or two can speak about it. So I'll just give you my introduction, then we can have at least a 1 or 2 minutes of discussion. Then accordingly, I'll plan my session. Though we have a broader topic, but we can get into some more detail how the industry works actually. So, my basic introduction here, like I have 11 plus years of industrial experience on bare metal programming, IoT. So, yeah. So, bare metal programming, IoT, DevOps, Linux system programming, Linux kernel programming, Yocto build system for various devices like AM335X and Semi for D2X. So, different control level, processor level, I have an expertise. And I authored around 25 plus international and national journals and presented my research contribution various prestigious conferences. I was also appointed for a couple of years in the central government initiative called DDU-GKY, that is central government initiative to have a Skill India program, which trains the young graduate to be placed. And like my participants to whom I trained, they are working in like prestigious college companies like Qualcomm and Merafra, Kolabra. There are many such like product-based companies they are working in today. So more than I have experience of 30 plus people got placed there. And I was also been appointed as a corporate trainer for various organizations where I taught embedded device drivers to young graduates as well as the people who are having 3 to 5 plus years of experiences. All right, so this is some basic introduction of mine, and let's go ahead. So this is where I worked with a lot of people, and this is just glimpse of it, which I worked and just to showcase. This is the student level products projects, but basically I work on the product company, which is around 150 years old. All right. So the agenda I have planned, but it is little open. We can have discussion and I can modify accordingly. So I just thought of going with the introduction to IoT, which most of you know, but I'll try to bring the industrial perspective. A lot of myths are there in internet. We'll try to break them. And some IoT high level architecture, which, and then I will go ahead with the hands-on coding. The session is planned and I have connected my hardware. So hopefully I'll open my camera and I show you the hardware and you can see the debug logs onto the screen. And apart from that, yes, we'll do some hands-on coding and people don't worry. I'll just go with a very basic coding, but wherever you have doubts, you can stop me. It won't be huge length of code. But of course, in the tomorrow session, I'll also try to push the data to the web server. There I'll try to tell you without actually having coding background, how you can manage the code as well. That will look into that also. And that's it. That's the whole idea is all about what I have planned for today and tomorrow. Probably I'll be completing a few things today and rest of the thing tomorrow as well. And we'll see some projects which you can work with your students. So before going ahead, sir, could you please, someone can speak out and say me here, do we, the participants are students, faculty, or a combination?
Uh, It's a purely faculty only, sir. There are no students.
All right, that's great. Okay, so from anyone from the faculty, 1 or 2 people can just unmute and say that what is your expectation like? Do you want, of course, I'll cover hands-on, that's other part of it, but do you want me to specifically cover something which can help you as well as your student once you go back to the classroom? Then probably I'll try to cover that also. Any 1 or 2 participants can unmute. Yeah, anyone? Hope you guys have to go back to the students and speak about it, right? So I just need you. All right, no problems. All right. So in which year IoT got started? Any idea? Anyone? At least very simple question with start with. In which year IoT started actually?
1999, sir.
99, 2000. Okay. Any other? Any other answer? Okay,
Maybe
let me
2010.
pop up. 2000, 2010, 2015. So the whole idea was started in 1980 and it was coined by one student actually. It was in 1982 where the first IoT product actually came with the Coca-Cola company. So just to brief you, and we'll not go into, of course, historical details, which is not my cup of tea at this point of time. So basically, there was a student who was working in the university for his third year project, and he used to actually go often to fetch the coke, and which he has to travel 500 meters from his lab. Then he decided, why don't I make this coke system automated, which will let me know that whether the cokes are available or not, because he used to travel and find the cokes are empty. Then he decided and approached the professor that can I do a project where I'll try to connect a Coca-Cola machine to the internet so that whenever the cokes are empty, I need not to travel there and see whether the cokes are there or not. If it is there, I'll get a message and I'll try to fetch my coke. That was the whole idea. And at that time, people was not even think of it. This small idea will actually have a revolutionary technology called Internet of Things. So very first device which was connected to the internet was Coke. Coke basically vending machine. All right. So we'll try to talk about this in detail a little bit. So let me just see if I can draw a little bit. All right. So, okay. So, but all right. Okay. No problem. So we'll see some more option. That's okay. That's not a deal. Yeah. So hope screen is visible.
Yes, sir, it's visible.
Yeah. So basically, the whole idea is like Internet of Things says that any device which you can name it is going to be connected to the internet. What it mean? We'll try to see a little more detail here. So we'll come back to this definition again if needed. So basically in 2015, once we go back and see, basically a personal computer and mobile was connected to the internet. That was the only two devices often we can see was connected. But few years later, when we went to 2020, other than mobile, other than laptop, we can see a smart TV got connected to the internet. That's what we say smart. Anything which is connected to net, they used to use a word called smart. Smart TV means TV got connected to the internet. Later, watch got connected to the internet. That's what we say smartwatch. Later, we can see a pet feeder system got connected to the internet that we call say basically a smart feeder system. Thermostat got connected to the internet, and the entire city, especially a city like Barcelona, which is in Spain, got entire city got connected to the internet. That's what they called as a smart city, where they have smart transportation, smart agricultural, smart waste management, many things. So name it, everything got connected to the internet. That's why they call it as a smart city. So we'll try to talk about this in detail if needed going forward. So basically, what else can get connected to the internet in the future then? So we have seen whatever got connected, but what else can get connected? So you may get wonder that your spoon can also get connected to the internet. This is, by the way, a product from a Hong Kong company. It's called Smart Fork. So basically, it will tell you how many calories you're eating per day and how many calories you're supposed to eat per day, and what is the delta between that. You are gaining the weight or you're going to lose the weight. Are you eating healthy or you're eating non-healthy? Everything it will tell you, and you'll get the display onto your mobile as well. So that is the level of products you can think in the futures are coming ahead. Pacemaker. So basically, people from the medical industry, it's a very popular device called pacemaker. So basically, people who suffer from heart attack, so they install a device called pacemaker, which actually try to pump the heart depending upon these electrodes. Now in future, these pacemakers are also going to connect to the internet. Similarly, a cooker, a microwave oven, even a shoes from Adidas, anything you see today is even a bulb, fan, which we know very well. Anything you can see today in future are going to be connected to the internet. So that is called as a Internet of Things. Any non-living thing. So you may think about what about the living thing, then humans. So hopefully Elon Musk can come up with that technology as well. So he's working on it. That's called brain technology, where he's trying to connect your brain into the internet as well by having some chip inside it. So I don't want to get into that's a different part of discussion altogether. Let's not get into that. But as this point of time on non-living things. But in future, if living things can also get connected to internet, we need not to wonder about it. But a lot of things comes into picture before to that. All right. So this is a a very small introduction just to tell you that any device you can see today around you in future, they are going to be connected to the internet. With this, lot of issues are also there, lot of security challenges, security breaches, data privacy, whatnot. Many things are there. So we'll try to cover because I cannot cover whole thing in one session, but maybe we'll try to see in chunks one by one. All right. So basically, to go ahead with IoT architecture. So what do you mean by this IoT architecture? And we will have hands-on in this. So my suggestion to all the participants, please pay attention to this one slide. After this slide, I will take a pause. If you have any question, I will answer them. And then after this slide, I will directly jump onto the practical and we'll see one by one. We'll go ahead and code something here. All right. So basically, this is called an Arduino. Most of you know about it, maybe. If you don't know, it's one simple electronic chip, I can say. It's peripheral device which has a microcontroller on top of it. And this is an Arduino. So this kind of devices are various. I will talk about this one by one. You can have Arduino as a device, which will have a microcontroller on it. You can have a Node MCU, which I have right now in my hand. I will show you after opening my camera. I have a Node MCU with me. So Node MCU is also one kind of device which will have a microcontroller on it. Similarly, you will also have some devices on which you will have a processor on it. Example, uh, BeagleBone Black. So there is a device called BeagleBone Black, which will have a microprocessor on it. Similarly, there is a device called AM335X, which is called SEMA A5D2X. So there's a chip device called just like this called SEMA A5D2X. On that is also I have, if possible, I'll show you. So that will have a microprocessor on it. Raspberry Pi, which is very popular, once again, will have a microprocessor on it. So please understand, there are some devices will have a microprocessor mounted. There are some devices which will have a microcontroller mounted. So basically, these are called as evaluation boards. So this is called as an evaluation board in short. So this evaluation board can have a microprocessor on it or microcontroller on it. Now, which one you should choose? That depends upon your application. So whether I should use Raspberry Pi or whether I should use Arduino. Raspberry Pi is a microprocessor based system. Arduino is a microcontroller based system. Okay. I hope it is clear. But you have to understand one more thing here. Microprocessor based system will run operating system. Microcontroller based system doesn't run the operating system. That's important. So I'm directly getting into the technical part of it so that we can code here. So let us imagine that you have one Raspberry Pi and you have Arduino. Arduino is a microcontroller based system. Raspberry Pi is a microprocessor based system. Microprocessor based system basically will have what? Operating system on it, whereas microcontroller based system doesn't have an operating system on it. But intermediately, a microcontroller based system can run RTOS, called real-time operating system. That's another different variant altogether. That's called RTOS. It's not even a OS, not it's a normal like controller. It is called RTOS. All right. So any doubt here, I'll take a pause before, because this architecture is very important for you. You already may be teaching this subject in your class. I don't know. But if you're not clear or you have doubt, please ask me. Then I'll go ahead. Any doubts here? I want to break down this architecture into some bits and pieces. Any doubts? All right. Then, so now what we have to do with this device? So we have to connect sensor to this particular device. So for microprocessor based system, we can connect the sensor, or to microcontroller based system also, we can connect the sensor. Which sensor we can connect? And what is a sensor? Anyone in the class? What is sensor?
Since the environmental changes like temperatures, weathers, if we are using in a irrigation purpose means water mm, qualities like that.
Great. That's nice, Divya. That's true. So any sensor basically detect the change in physical parameter. So basically in our body also we have 5 sense organ: eyes, ears, nose, tongue, skin. So please understand this sensor, what they are doing in our body, what eyes is doing. It is sending a signal to our brain. What hand is doing, like our skin, pleasure and pain. This will send this information to our brain. What our ears are doing, they are listening this sound and sending to our brain. Like similarly, tongue, taste, what it will do, it will send to the brain. Similarly, sensors, what it does is they will detect the environmental changes and convert that changes into electrical signal. I'll give you one example. Someone is raising the hand. I'll get back to them. So example, temperature sensor. It will detect the change in temperature, convert into electrical signal, give it to the controller. Okay. And similarly, if it is a humidity sensor, change in humidity it will detect, convert them into electrical signal, give it to the controller. Likewise, we have 300 sensor today. We have nearly 300 sensor today. Okay. So anyone, you have any question here? Someone raising the hand, I can see. All right. All right. Okay. So basically, we have around 300 sensors. So one thing we have to understand, if it is a microcontroller based system, you can connect the sensor directly. But you have a microprocessor based system, then you have to have a ADC in between. So sensors are connected to ADC and ADC is connected to the processor. So if you are using a Raspberry Pi, you cannot connect the sensor directly to the Raspberry Pi. You have to have a ADC in between. But if you are using a microcontroller based system, you can connect sensor directly because microcontroller will have on-chip ADC. So people who are teaching MC and MP, microprocessor, microcontroller, they know about it. So microcontroller will have on-chip ADC. So therefore, you need not to have an external ADC. So in a nutshell, if you are using microcontroller, sensors can be directly connected. If it is a microprocessor, sensor are connected to ADC and then ADC is connected to the microprocessor based system. So for Raspberry Pi, you have to have an ADC compulsory. Okay, that is one point. Now, one more point. If the ADC is 8-bit, your sensor value can range from 2 to the power of 8. If your ADC is 16-bit, your sensor value can range from 2 to the power of 16. So depending upon the size of ADC, sensor value will change. It can change. So the higher the ADC value, ADC unlock to digital converter, basically ADC. So higher the ADC value, the more precision will come. So that is the reason why in medical application, you will find 24-bit ADC, 22 to the power of 24. Very small change it will detect. So in medical, we'll have a 24-bit ADC, by the way. However, okay, let's go ahead. So what's there next? So now we have to interface these two, okay? Now to interface these two, what we have to do, we have to write a code. So there are basically two ways of writing a code. One is called manual coding. I have to type. Another is called graphical coding. I will not write any code. I will just drag and drop, and it will have a code itself. So I will teach you both the method today. So I will teach you how to write a manual code also. I'll also teach you how to write a graphical code also. So it will help you, especially when you go for IoT web server application. Graphical coding will be very easy because with few clicks, you can have a code ready for you. I'll show you that tomorrow, in fact. Okay, so far sensor to Arduino interaction or sensor to node MCU interaction we have to do. It should read means we have to write a code for that. Which type of code I can write? I can write a manual coding, I can type it, or I can use a graphical coding. This coding is called embedded C. Anyone in the class? What is the difference between C and embedded C? Anyone? Anyone in the class? So you guys expect answer from students, right? Yeah, please, anyone. What is the difference between C and embedded C?
C is normal programming language,
Okay.
whereas embedded C means the C commands are integrated with uh, machine related code. Sometimes Oracle means SQL along with C will be called as a ProSQL, like that. So if you embed that C program in any machine to work, it automatically will call it as embedded C. For example, embedded systems.
Okay. Okay. So to
Some of the
rephrase,
IC chips, will be
IC chips like that also.
coded in C.
Coded with
So
C.
usually hardware is embedded with some
Hardware and
software.
C were
Can
integrated.
yeah, please. Yes, please.
C is a programming language. We can connect with the OS.
Okay.
In embedded C, we can connect with the hardware directly.
Okay.
We used to control.
Okay. So most of you are correct, but little rephrase I have to do. So very simple. Whenever you write a C program, you mean to run that program onto the desktop. But whereas you write an embedded C program to run onto a target machine. Here the target is Arduino. So you cannot run a simple C program. You can run C program, but here we have to have a registers. We have a register. People from microprocessor controller, they know T mode, Tcon, that kind of registers are there, which configures the hardware. But whereas in C, we need not to worry about the register. So it's independent to hardware. It's a hardware dependent. Depending upon hardware, you have a header file. There you have a header file related to your computer. Here you'll have a header file related to the hardware. New hardware, new header files will come into picture. Okay. So we can go in little more detail when I code it. All right. So next point. So I have written a code. Like what next? Now what should I do? So now I should connect this to internet. Then what I needed? I need a one chip. Basically, what it should do, it should internet enable my hardware. Example, in my mobile, I have a Wi-Fi module. In my laptop, I have a Wi-Fi module. But in Arduino, you don't have a Wi-Fi module. In Node MCU, you have a Wi-Fi module. So that is the reason why today I will teach you Node MCU programming. Same like Arduino, but it will have a Wi-Fi module on chip. So what will happen? It can connect to internet. Arduino cannot connect to internet directly, but there is another chip you have to add called ESP32 or ESP8266. There's another chip called ESP8266. If you add the ESP8266 to Arduino, then it can connect to the internet. But I don't want to have another piece of hardware, so I bought a very simple 350 rupees device called Node MCU, which will have on-chip Wi-Fi, will be connected to the internet. But when I say internet, where it should have a router in between. So that is called gateway. So in diagram, that gateway is missing. I'm just telling you here you'll have a gateway. Simple. Your mobile, when you go to home, you want to connect your mobile to the internet, you have your Wi-Fi router at your home. Similarly, that Wi-Fi router is called gateway. If not, then you have to use your mobile data where your tower is connected. Via tower, you will be connected to the internet. Okay, in that way. So if you are not using mobile data, then you have to use a router. So similarly here, I'm using my home router. I'll show you tomorrow. I'll configure SSID and password. So I will SSID password of my router. I will keep in my code so that it will connect it to my router. From router, it will go to the internet. That I'll show you tomorrow. Don't worry. All right. What next? So there is a gateway, means a router, and it will push the data to the cloud. Now, what is the cloud? Very simple. It's a remote machine. Very, very simple. It's a remote machine. Now, why do we keep the data into a remote machine? There are many reasons for that. We can monitor the data because I don't want to monitor locally. If I have data at my level, what I can do? If my manager want to see, my director want to see, my clients want to see, my customers want to see. So where they can see, they can't open my laptop. It is my laptop. So therefore, I will push the data into the cloud and I'll give the cloud access to them so that they can monitor. They can see the runtime data. So we will see tomorrow. So I will take one example of cloud. Practically, we will configure that cloud. Tomorrow we'll do that because that session I'm parking it for tomorrow. So example of that cloud, there are many such cloud, AWS cloud, Azure cloud. So we are using ThinkSpeak as a cloud here. It's from MATLAB. It's a very simple cloud called MATLAB. From MATLAB, there's a cloud called ThinkSpeak. So I'll be using that ThinkSpeak as a cloud. I can monitor. Monitor means my sensor data, whatever I'm sending here, it will be on the web application. Here like this, you can see the bar. And I can control also. So what I can do, I'll show you how to control. I'll give you one example of that. And third thing is that you can even monitor and control here. Three things you can do. You can monitor, you can control, or you can monitor and control. Now, what do you mean by that? So you can have one web page. You can design one web page using HTML. And then what you can do, you can configure the buttons so that you can control the LED. Let's say you have written a program to control the LED, put that into the server. And here you have to prepare a dashboard, something like this. And here you'll have turn on, you can see LED turn on, LED turn off kind of buttons. So once you press this button, these fans, these LEDs will get controlled. From where? So sitting here, I can control from even New York LEDs. I can control from even Australia. I can control any LEDs across any world in the planet. So anywhere in the world will have a unique IP address. I can just click that and control. So for this, I have to know the how to have a web page. So I worked on having many web pages in my past. So, but that's beyond the scope of our today's and tomorrow's discussion. Maybe some other day we can think of it. All right. That's one thing. And similarly, there is one more application called Blink, so which will allow you to monitor and control both. So this looks something like this. So all these three things which you can see on the screen, I personally spend good amount of time in my life working with them. So ThinkSpeak, you can monitor, In controlling, you can design your web pages to do that, or you can use simply a third-party app called Blink, which is a free of cost, which will help you in monitoring as well as in controlling. So you can install this app and you can try with this. But of course, for that you have to do some more addition in your coding because you have to access the Blink libraries also. All right. So till this, I just want to take a pause and answer if you guys have any questions. Over to participants. Any questions? Looks little complicated or okay, okay? All right. Let's go ahead. So to summarize, let me have a small summary here. So let's go ahead and we'll have a sensor which can be connected to a device. This device can be microprocessor based system. It can be microcontroller based system. If it is a microcontroller based system, that is called as a bare metal programming. So this programming language, technically we called it as a bare metal. Today we are going to write a bare metal programming. So if you see in my introduction slide, I have mentioned there, I know bare metal programming. So this is called bare metal programming technically. So this bare metal programming will configure this microcontroller. Similarly, for microprocessor also, we can configure by writing code. We can choose any programming language, whichever the hardware is supporting, whether it's a Python or whether it's embedded C or whatever. And sometimes you can even use RTOS based system. That's called real-time operating system, RTOS based system, which is a microcontroller again, which is once again a microcontroller, which is not a microprocessor. So once you have decided which particular sensor, depending upon the project, you will be selecting a sensor. Depending upon your project need, you will be selecting a particular device, whether it's a controller, whether it's a processor, and then you will be selecting a programming language as per your expertise, as per the hardware supports is required. All this you have to understand. And then you have to use a gateway in between to push the data into the web server. So once again, you have a lot of choices in the web server. You can use Amazon web server, you can use Azure web as a web server cloud, I mean cloud basically, or you can use a ThinkSpeak as a cloud, whatever, depends again, once again, on your project need. You can monitor once the data is there, or you can control, or you can monitor and control. When I say control, you cannot do that control directly in the ThinkSpeak. For that, you have to host your own local web page. And for that web page, you can control once again. So for this, you have to write some more logic in your coding. Or if you're using third-party app Blink for monitoring and controlling, this Blink libraries and Blink command APIs you have to add here. Then you can control also. So setting here, you can control anything, almost anything which is connected to the internet. All right. So this is a summary. All right, so far so good. So let's go ahead and see what else we can do. So let's have an activity. So basically what I'm going to do is I will try to configure the node MCU and then show you. All right, so this is a node. Of course, I'm not going to explain the pin diagram, but this is something I'm using. I'm always skipping here. So always remember, anything you get it out, you come back to this diagram, refer it. Example, which pin I should connect to the LED. So which pin I should connect to the sensor? I should come here. These pins are reserved. So any pin you cannot connect. So you can see sensor win. So GPIO 39 is only reserved for sensors. So here you can connect one sensor like this. You can see one sensor you can connect. Similarly, you can see if you want to connect UART 16 and 17. So likewise, if you want to connect any touch device, you have to connect to this particular ADC. So that's what I was telling you. Have on-chip ADC. You can see it is having on-chip ADC. That is the reason why we are not connecting external ADC. For microprocessor, you will not have on-chip ADC. So therefore, you have to connect external ADC. That is a point. Okay. And this is I2C pins. That's called in-circuit protocol I2C. So there are a lot of advantages. I don't want to get into that detail because using these two pins, you can connect up to 128 sensors at a time. So very, very powerful protocol this is. All right. So this is called Node MCU, or basically called in short ESP32 WROM. So in ESP, there are a lot of series. I'm going to use this particular series. All right. So let me show you guys. So let me turn on my all right video. Oh, I don't know whether I'm visible or not. So let me just. All right. So this is something. This it's look like this. All right. So this is something I'm holding in my hand. And there is another sensor. Of course, I will not be interfacing sensor directly. I will be showing the sensor to you after some time. And this is the device connected right now. And in fact, not connected. I'm holding it. I'll connect it later. So let me do a coding and then connect it. So let's write our first bare metal programming. All right. So I'm turning off and then I'll turn it on again. Okay. So any questions so far before I go ahead? Because I'll jump directly onto the coding. Don't worry if you don't know coding.
Hello.
If you know, yep, yeah.
Sir, when we have to use a microprocessor and when we have to use microcontroller, sir, particular case?
So I can say you any application which is very small in nature, example, which is a dedicated application. Especially you can see a microwave oven. It will do only heating. If you see example your washing machine, it will do only washing your clothes. In any application which are doing one particular job repeatedly, in such cases, you will go for microcontroller. But any application which is independent, example, your laptop, which is independent. So today you will be running A software, tomorrow B software, day after tomorrow Z software. Anything which are not application dependent, you have to use the microprocessor because OS is there in that. I can give you one more example. Anyway, touch is involved, touch screen is involved. Mostly we will go for a microprocessor based system. So your watches are today is a microprocessor based system. Your smartwatch is a microprocessor based system. Internet of Things, wherever you see touch is there is a microprocessor based system. It's not a microcontroller. But having said that, can I go in little detail if everyone is okay with it?
Hello, sir.
Yeah.
Can we attach camera to microcontroller Arduino?
Yeah, you can. You can attach camera. The camera is nothing but
Is model is available for that camera model?
yes, camera module is available. Camera is just nothing
Uh,
but one of the input device to the
okay.
microcontroller.
Oh.
Yeah. So I just want to tell one thing someone's asked. Yeah. So here one point. I'll just take a little bit pause here to make you a little more understand. See, any microprocessor based system, I said operating system is involved. You can have lot of load over it, so it can do multitasking. That is what we call threads. We have multi-processor, multi-threads. So you have to do many things at a very faster rate. Then microprocessor will come into picture. You want to do only one thing at one speed, microcontroller will come into picture. But there is one more problem. There are certain applications which required operating system, but not so heavy. That's where you will use real-time operating system called RTOS. So real-time operating system example is like ThreadX, Nuclear OS. They are different. Nearly there are 200 plus RTOS are there in the market. So ThreadX, Nuclear OS, this kind of real-time operating systems are nothing but free RTOS. There's another OS called free RTOS. So what that free RTOS will do, they will have a bare minimal OS running on top of the microcontroller. On top of the controller, bare minimal OS it will run. That is one thing. Okay. And they are time critical. So RTOS are time critical. So you may ask where it is useful. I can give you very simple. Anywhere life threatening is there, they will use RTOS. Example, missile launching system. There you will not find OS, you will find RTOS. Your banking system, sometime you will find RTOS because they are time bounded. If I launch a missile, it should be time precision to launch at a particular interval of time. OS will have a delay, but RTOS will not have a delay. So wherever the life is important, wherever very critical time analysis is needed, they will go for RTOS there. Okay, that's one thing. All right. So any other doubts before we move further?
Sir, in mobiles, we are using microprocessors, the controllers, sir.
Processors. In your mobile, you have a processor.
Okay, thank you.
Hi, sir.
Yes, sir.
Sir, in case we collect the data, microclimate data using IoT device, agriculture, arable land.
Sorry, sir. I can't hear you properly. There are small disturbance. Can you be a little more louder?
Sir, in case we collect the data using IoT, the data is microclimate of arable land, agriculture land.
Okay.
How as a researcher can plan to collect the data using IoT devices
Mm-hmm.
at small scale level,
Mm-hmm.
which must benefit the small scale farmers,
Mm-hmm. Mm-hmm.
or
Okay.
go by microcontroller or
Okay. So let me help me understanding whether I understood your question properly. You mean to say is I have an agricultural application where I want to measure bare minimal data. In such application, whether I should use processor or I should use any controller based system. Is my understanding is correct, sir?
yes sir, but the domain concept is microclimate data, which
Okay.
we collect some temperature, humidity,
Mm-hmm.
some of the five parameters of microclimate.
Mm-hmm.
The climate and microclimate are different.
Mm-hmm.
That's why how the small scale farmer can plant
Mm-hmm.
using the adaptation of IoT.
Simple, sir. So for me, it's hardly matter whether it is a climate or a microclimate. For me, only as a technical guy, only matter what you want to measure. For that measurement, sensors are available or not. First thing. Example, you say that I want to measure, let us say humidity. I'm just giving example. I want to measure the humidity.
Yes,
Humidity
yes.
sensors are available. I want to
Okay.
measure, let's say temperature. Temperature sensors are available. I want to measure a soil content, whether the soil got contaminated or not, whether the soil quality is there or not. Those kinds of sensors are available. If those sensors are available for me, I'm happy to interface with my hardware, push the data to the cloud. Now I leave it to the data analytics guy, how you will analyze the data, because there are some standards of doing data analytics. They will do the data mining, they will see the data quality, they will project, and there on top of that, if you apply I mean machine learning algorithms, you'll come to know that now it is good, in future it may become bad, or vice versa. So for me, as an IoT, see, always remember there are two things we have to understand. IoT is feeding the data. AI/ML is taking decisions on the data. And people who are business people, they are earning from that. So there is one person who is fetching the data. There's another guy who's managing the data. The third person who's actually earning from the data. So that is why we call data is a gold. Today, data is a gold, data is a diamond. Okay. So for your answer, to answer your question, any application, it's irrespective whether agricultural, whether industrial, whether A, B, C, D, no problem. Do we have sensors for that? Which particular parameter they want to measure? You have to do the research there, first point. So I got a application where I want to measure the quality of a water. Watch quality of a water. In water, there are hundreds of things you can quantify. Which one? So they said I want to have a RH value in the water itself. For that, I have a sensor. Okay. I want to check the purity of a water. I have a sensor to check that. That's okay. But I don't have a sensor, then I will have a limitation. So there is no sensor available. We can't go ahead from that. Did I answer?
Yes, yes, yes.
That's all right. Okay. So, right. So I hope I have shown you guys device. So now this is a time for us to go with the coding part. Okay. So here, basically, let's say I'm very new. I don't know what to do. So there is a IDE installed called Integrated Development Environment, IDE. So now what is IDE? See, these are like little fancy terms look like, but they are very simple. It is a place where you write your code. You will debug your code. Now, what is debugging? If you want, I can go ahead and explain later. But it is the place where you will write a code. Integrated development environment. It is a place where we will type our code. But it is not like a text editor. So you can say that I can type my code in text editor also. Then why ID is different? So ID is not only writing the code, but it is also compiling the code. Not only compiling the code, but whenever there is a bug, it will tell you where is that bug also. That's called debugging. So you can write the code, you can compile the code, you can debug the code. Earlier, there were three different software they used to do. Now everything is done by one software that's called ID. So writing is an editor, compiling is a compiler, debugging is a debugger. All these three are combined as a single software. They call it as an ID, Integrated Development Environment. That's it, very simple. So you can download ID from here. And then you have to configure NodeMCU because this ID support hundreds of devices. Out of that, the device which I'm using, I should configure that. Write my program, connect the hardware, check the output. Very simple. All right, so let's go ahead and do. Okay, so let me open. So this is my ID. Now, people who don't know, you can just browse it, how to install the ID. You can install very immediately. All right, so let me disconnect my earphones and then so that I can connect my hardware. One.
Hope my voice is audible.
Yes, sir.
Yes, sir,
Audible.
audible.
Yeah. So, yes, sir, audible. Yeah, thank you. So this is the place. This is called ID. This is what I was talking about, integrated development environment. So here we can type the code, which we are going to do now. And then you can see that we can compile our code. We can download our code into the hardware. Okay. Now what to do? So let me write my first simple program. So let me just see if I can, okay, write something here. So I was being used, I think after a very long time, I'm using this. So if I can write something here, okay. If not, okay, there is a annotation option used to be there. So I'm just trying to check for that so that I can write. If not, then let me, I'm sorry, it's long back I've been using this. Okay, no problem. So, so let me open Paint.
ID is not visible.
Yeah,
Sir,
yeah.
we are not able to see the writing screen. Sir.
Okay, so let me share. Let me share. I hope now you can see.
Yes, sir, now it is visible.
Yes, sir.
Okay, thank you. So now, my friends, here, so let me write this. So here we have a one device called microcontroller. Okay. So now to the device, you can connect some input devices. Input devices are called sensors. I'm writing in short. S means sensor. Sensor is a input device. Similarly, you can have output device. That is called as actuator. What it is called? Actuator. So sensor is called input device and actuators are called output device. And this is, let us say, called as a microcontroller. So for a microcontroller, input devices are sensors. No, and one more thing, all sensors are not input devices. Example, button. Button is an input device, but it is not a sensor. Okay. Switch. So all input devices are not sensor. You have to understand. So that's the reason why sensor are one such category of input device. Similarly, button is also an input device. Output devices are called actuators. So example of output devices are like buzzer, LED, motor. So these are the output devices. Sensors are nothing but I told you, temperature sensor, humidity sensor, soil moisture sensor, RFID, button. Many things are there which are input devices. And this is my microcontroller. Now, just like a Hello World program for C who learns for the very first time, in microcontroller, any embedded programming, we call it as a LED blinking. So LED blinking is like a Hello World for us. So any new controller, any new processor, anything when you first time take the first code you will write here is a LED. Similarly, whenever you write Java, Python, or C or C++, you will be writing first program as a Hello World just to take that, okay, everything is working. So for us also, LED is just like that. If everything is working, it should blink the LED. So that means that I did everything smoothly so far. So therefore, I'm starting with my basics. So let's go interface the LED and blink that LED. So is the concept is clear to everyone or any doubt?
It's clear, sir.
All right, so let's go ahead and code it. All right, so now, first thing what we will do. So we have to understand which pin we are going to connect. So we have to refer this. So these are called GPIO pins. To any GPIO, generally we can connect the LED. So general purpose input output pins. So any input output pin, whenever you see GPIO, you can connect the LED there. But for this, I have to connect one external LED. So I have to bring one LED from the market and connect to any one of this pin. So pin number 36, 39, 34, 35, 32, 33, or 25, any such pin, I can connect the external LED. But now I don't have LED with me. So what can I do? So on chip one LED is there. So I will repeat, please listen. On chip one LED is there in the node MCU ESP32. On chip LED is there that is connected to, with my experience, I'm saying it's pin number 2. So pin number 2 is connected to this, you can see on chip LED. So if I configure this LED, I mean this pin, it will blink the LED. But you may say, sir, no, I don't want to configure 2, I want to configure 3 or 16. You can do that, no problem. LED will not glow on chip because it is not connected. You have to bring from the market and connect, it will glow. It will turn on and turn off. Okay. So hope it is clear. All right. So now let us write the code. Now, general practice. I will take, okay, so here, by the way, void. So generally, there are two loops in Arduino. One is called void setup, other one is called void loop. So these are by two default loops are there in this ID. Now what these two will do, this will run only one time. Anything you write inside this loop will run only one time. This will run continuously. So whatever you write inside this loop will continuously run. Okay. So these are the two things you have to understand. Okay. So two things. What are the two things? Anything you write here will run one time. Anything you write here will run multiple times. Okay. So let us get back. All right. So let me erase this and okay. All right. Otherwise, let us do one thing. Okay. Okay. So now here, this is my microcontroller. And I know that in this microcontroller, that is ESP32, pin number 2 is connected to where? Connected to where?
LED.
Now I want to, what I should make? This LED should go what? On?
Off.
And off. I hope it is clear to everyone.
Yes, sir.
Okay. Please understand, this pin will have 4 functions. How many functions? 4 functions. Number 1, this pin can behave like an input pin. Second one, this pin can behave like an output pin. Number 3, on this pin you can write high. High means 5 volts. 5 volts. You can write low. I'm writing in short, called 0 volts. So one pin will have how many functionality? 4 functionality. Input, output,
high, low.
Low. Please understand, this LED is input device or output device?
It's an output device here.
So in this case, it's an output device. And I should toggle between these two, high, low, high, low. So I will configure pin number 2 as an output device and toggle between 5 and 0 so that you can see the output. Any doubt here?
No.
All right. So I'll repeat it again. I have a microcontroller. Pin number 2 is connected to LED. LED is a output device. Any pin will have 4 functionality: input, output, high and low. Input is connected to sensor, so I'm not using sensor, leave it. Output LED, I'm connecting as an output device. And then I should toggle between high and low so that you can see the output. So that's what I'm going to. So this is theoretically, this is what we are going to do practically in the code. So let me connect LED is equal to 2. And now I should say that pin mode, LED is which device?
Output device.
Output device. Clear? That's all. Okay. So now what did I do? I said LED, which is pin number 2, and this pin number 2 is a output device. Now what should I do? I should toggle between high and
low.
Okay, so one last point. So to do this, input and output. So to do this, input and output, you have a command called pin mode. To configure input and output, you have a command called pin mode. And to do high and low, you have a command called digital write. Please understand. One last point.
Digital.
Digital write. So
Okay.
to configure a pin as input or output, you have a command called pin mode. To configure high or low, you have a command called digital write. So I'll be doing that. Don't worry. So now you can see that I will be writing here digital write LED is which device? Sorry, it's output device. It's high. High means what?
5 volt.
5 volts. Or you can say LED on. Clear?
Yes, sir.
And digital write, what should I do?
Low. LED low.
LED
Low.
low. Which is nothing but LED
0 volt.
I mean,
Off.
I can say, yeah, because 0 volts, which means
LED
LED off.
off.
Any doubt? Anyone in the class? Any doubt? Almost I'm done with the coding. I'll do one small change here. So what this is
Sir, I
saying?
have one doubt.
Okay, 1 minute, just 1 minute. We are saying LED is a
Output device.
okay. Yeah, please. Yes, please.
Sir, these programs are in a case sensitive, or we use uppercase and lowercase both, or if we, for example, you are writing a digital, right? A W is a capital and pin mode M is a capital. It's an case sensitive, or
they are case sensitive. They are case
okay,
sensitive given by the Python library. If you don't write, it will show you error. Example, if you
okay.
write like this,
They will
generally,
show
to
an
best of my knowledge, it should throw you some error. Okay.
Okay, sir. Thank you, sir.
Welcome. Now, so far, so good. Any doubt here? But if I do like this, 0 to 1, it will go very, very fast. Very, very fast. Your eyes cannot see. Because
Yes.
human eyes cannot see the difference between on and off. So to see the difference, add some
delay.
So delay. 1000 means what? 1
Millisecond.
millisecond. You turn on for 1 millisecond and then what? Turn off for 1 millisecond.
1 millisecond.
Is that clear to everyone? Now you will ask me why I'm writing here. I want to turn on and turn off one time or continuously?
Continuously.
Continuously, right? Turn on, off, on, off, on, off, on, off. That's why I have written here. But how many times I should say LED is output device? One time or every time? One time. So if I say one time that LED is an output device, that is sufficient. I need not to tell every time that LED is output LED. One time is enough. That's why I have written here. But I have written here because I want to continuously toggle. This is called toggling LED. What it is called? Toggling an LED. Okay, so here we'll write toggle LED. Any doubts? But there is one problem here. What is that? So I want to see this LED output also in serial monitor. If I do like this, I can see the output in the hardware, but not on the screen. I want to see the screen also. So for that, what you have to do, serial output. So don't worry what I'm doing. This is basically configuring the serial monitor.
What is that 9600?
1 second. Configure serial monitor to see. Okay, so that is called as a baud rate. So 9600 is called as a baud rate. Now, what is a baud rate? It is a speed between your computer and hardware which they are talking. So that is called UART. So people, it will go a little more technical. So I'm not explaining, but just for you, 9600 is called baud rate of UART, Universal Asynchronous Receiver Transmitter. So in short, at which device and computer are sending data. The baud rate of UART, speed at which the device and computers are exchanging the data. So similarly, you can have different values of UART. So once again, it's a different altogether a story to explain, but I'm keeping it very simple. Itself will take some long time. So once I configure this, I have one option to use called serial dot print ln, new line ln. I can print here now what LED is on. I can print like this. If I configure this UART, I can print the LED on the screen status. And here what I will print, I will print LED is off. Any question? Over to participants.
No, sir.
So this is LED is on and off. Okay, so we can do some like this. So just to ensure that everything is clean. Okay, so far so good. All right. Now let us do the one compilation. Here, I'm not connecting the hardware, just verifying any syntax errors are there. Just compiling and verifying. So compiling is in progress. I have not connected the hardware yet. I will turn on my screen and show you. So serial is S capital. So serial dot println. It is SS capital. You can see it is throwing the error. So I request someone like has unmuted themselves. So I'm hearing sound. Please mute yourself. Okay. So compiling is done. Means which what? There are no syntax error, and it is so far it's good to get into the hardware. So what this is called as bare metal programming. What they are called as, technically called as bare metal coding. Language is called as what? PD. So bare metal coding you call, language is called as what? Embedded C. So just for your information, I have written. All right. Now, this the time has come. So, okay, so let me open my screen and show you. All right, video. Okay, so let me see. Okay, so this is something the hardware I'm holding in my hand. Okay, so let me disconnect the sensors. Not required meanwhile. You can see that after some time. So you can see the code. Okay, code is here. I mean, sorry, hardware. Hardware is here. And now I'm connecting. You can see the other end of the cable to my PC. Okay. You can see something like this. Okay. Now what we will do? So I have connected the hardware. So after doing this, so let me just stop the screen and then let's do this. Okay. All right. Oops, I think it's stopped sharing it. Okay. I hope it is visible. Screen is visible. Yes, no?
Yes, sir.
Okay. Now what we will do, see here. You have to go to tool chain. For the very first time you have to do, not every time. You have to see two things. Your device name and your COM port. So in my case, since it's already detected, it is showing 3. For the very first time when you do, these two things you have to do. So don't worry, you can take the help of internet if you have any doubt. This is called WROM device. So there are many such devices. I told you, like you can see I'm using this device. I'm using this particular device. So if I go to tools and show you here, I am using this particular device, which I have shown you just now. Similarly, there are these many devices in the market. Which one you will use? I don't know. This one you will use or this one you will use. Which device you can see Arduino, ESP30 Dong, you can see Inventor OS. So there are many such devices. So I don't know which one you are going to use. But since I am using this one, I clicked this one. So you have to select. So where you can find that? You can find that in your device itself. So on top of the device, you can see ESP32 WROM, this name. And this is like a computer COM port number. You can see you may get 3, 4, or 5, whatever. Okay. So these two things. Now code is compiling. I am deploying the code. So this is called deploying the code. So I'm just clicked on it, and you can see that it will start deploying. Okay. Okay, it should be here, not in the debug server. So let's see. Okay, so it has connected. So you can see some debug messages here will be running. If not, we'll see. This is some previous value it's showing. Okay, still it is compiling. I'm sorry. I didn't check. Okay, so it's compiled. Compilation is done. Now I'm deploying. So what it is showing some error. What it is? Okay, OpenGL cannot find the debug. So I did not touch the debug part of it, right? So, okay, so let me check. It's configured properly and the WROM device is selected properly. And then, okay, so let me disconnect and reconnect it again. So did I serial monitor? Okay, everything is perfect, 9600. Why it is showing open OCD error license under GPL? Okay, so maybe because of this or what, I don't know. Sometime. Okay. Did I press this? No. Wait, just hang on. Okay, so it's now sketch compiling is happening. This one I pressed. Upload. Now you can see, yeah, it's uploading. So you can see it has detected the COM port and it started, like you can see 100%. All right, so here we go. So let me just show you the video. And let me just show you the output. So you guys can see. Hope it is visible to everyone.
Yes, sir.
So one is power on LED. Don't worry, that is red color. That is a power on LED. The blue one is actually the LED which I configured. Now, if I change the delay, let's say on the screen, I'll make it to 2 seconds. And I'll make it to 2 seconds. And I will save this Control S. Okay, so I'm just saving this Control S. And let us upload this code now. So now you can see on the screen that it will be now little slow. Blinking will become little more slow. So this is a on-chip LED. That is the reason why I'm not connecting some external LED. Otherwise, if I configure another number, I have to connect the external LED. Now you can see the LED blinking got stopped because the code is getting uploaded. So once the uploaded is successful, you can see that now you can see on and off time. It's more time on and more time off. That's 2 seconds. 2 milliseconds. Sorry. Clear? Any doubt? And last, we'll do one more. We'll just go to 4000 and then we'll just save this and then we'll upload. And then we'll go to the sensor also. We'll interface and sensor and see the output. Now you can see it will be more time on and more time off. All right. So shall I turn off or any doubt? Okay. Now, so before I go ahead with the sensors, let's get back to our screen. Okay, so I think I'm sharing. Hope you can see my PPT now.
Yes, sir.
Yes.
All right. So any questions before I proceed further with the sensor? Any question? So by the way, in this diagram, if you see where we are, so where we are right now. So if you see in this diagram, basically what we are doing, we are just connecting these two and checking the output. Okay. But, and one more thing I will just want to tell you. Okay. So if you remember, I told you you can do graphical coding, right? So do you want to see the graphical coding? Yes, anyone? Let's do it.
Yes, sir.
Okay, sir, I don't know much about coding. I'm
So,
not so good at coding. So what else I can do? You can do something like that. So there is a website called Tunoid. Get here. Now, get into this. Let's say you're not so good at coding, then my suggestion, you can make use of this website as well. Okay, so, but of course, okay. All right, so this is what is the interface look like. So you can see blocks, code, and HTML, XML. So here you'll have a startup loop, you will have a main loop here. So these are what we have seen now. So what we can do here, let's say you can mention your PIN number. So you have to have digital, right? So you can see that what I'm using, LED, high, okay. Instead of this, I can also use one thing. Let us delete the block. Go to here, you can use this. So what is our pin number 2 na? That is pin number 2, but digital pin number, we will say D4. That's how it looks like. Okay. This is for on. And then what you have to do? You have to give some serial print. Say LED on and add some delay. And now you just copy this. Just you can copy this or simply go here, no problem. Use this low, duplicate, LED off, okay, and then duplicate. Hope I am correct. Hope you guys can hear me. Okay.
Yes, sir.
Yeah. So this is the code I have written just now. And just go here and see.
Hey, it's really easy.
You can see the code. Can you see? So this is the
Yes, sir.
blocks and this is the code. So you can see why it is taking 2 pins. I'm not sure. D4. Oh, okay. Forgot. Okay. Now fine. So you can see that. So just copy this code from here.
Same to what you are
And
writing.
just what you do, go here and paste it. That's it. So you can do Control KF to end line. That's all. So you can see your code is ready. Nothing to do. So whatever I did in that much time, it's there in front of you in a piece of cake. Just use it and deploy it. Upload the code and your LED started blinking for you again. So once it is uploaded, you can see that your LED will start blinking. So let the sketch gets uploaded. I'll show you that as well. So delay is 1 second. I am okay. So getting uploaded. All right, looks so smooth so far. Yep, it's done. So you guys can see now. Okay, so let me just show you. LED is ready for you. It's blinking. All right.
Yes,
Any
sir.
questions? Okay. So in this way also you can. So that this is called as basically what? Oops, where I am. Yep. So here, so this is called as what? Graphical coding. This is called as what? Graphical
Graphic.
coding. Graphical code. So you can use. So I suggest tomorrow when I go with the configuring the web server, I will be using a graphical coding because it's keep typing. It's of no use. So I'll just drag and drop and code it within no time. So just earlier I used to take some good amount of time to code. Now hardly I'll take 1-2 minutes, drag and drop, paste it and run the web server. It will be, so web application will be very easy. Okay, fine. So now the last thing for today's session, what I have planned for you guys. So let's connect the sensor. And then we'll be okay. We'll be at new page. Do not save this. Okay. So any questions before I move to the sensor? Over to participants. I'll take 1 or 2 questions. If you have by 9 o'clock, we have to stop. So by the time I'll complete the sensor as well. Over to participant. Any question? All right. Okay. So now what's the next thing? So why I'm choosing the sensor? Reason is you have to know how to connect one input as well as one output device. That's the reason why I've chosen sensors also. So I beg your pardon for my bad handwriting. So I'm not good at that. So this is my microcontroller. Basically here I'm using ESP32 or Node MCU, whatever you name it. And I'm going to use what? Since we are talking about agricultural applications, and fortunately, to be honest, I have a soil moisture at my home. And of course, there are a few more sensors at my home, but I felt this is the right topic to discuss it. So soil moisture sensor, how it look like, I'll show you. So this is a soil moisture sensor connected to one analog pin. Basically, which pin? Analog pin. So basically, I told you, right? So you will be having a pin modes. So now, so what we have to do, we have to configure pin as what? Input pin. Input pin. And now we are not going to write any high and low voltage because sensor will read the value. So from where the sensor will go to get the value also, I'll show you. So simple logic. So here I'll show you the connection. There are 3 connections. One is this sensor does not have a power. So Arduino, I mean this node MCU will give the power. So that is called VCC. 5 volts power supply and ground. So these two, power supply and ground, from Arduino or node MCU or any chip, sensor will get. So that's the reason why sensor will turn on. Otherwise, sensor will not turn on. So to turn on the sensor, we require the power. From where the power is coming? From the microcontroller board itself. So these 2 pins are for that. And then a pin is configured to read the data. Okay. So, all right. So having said that, let us go back and see where I am. Where is my PPT? All right. So good. So far, so good. Okay. Oops. All right. So we have covered this, covered this, covered this, and covered this. Now, of course, 4 LED you can do. So soil moisture sensor. So now this is called a soil moisture sensor. So how it look like? Let us try to understand. So when you keep these sensor nodes, these two, inside the soil, it will tell you the soil wetness, minimum to maximum. So what is the minimum value, maximum value? Depending upon the ADC. If it is 10-bit ADC, 2 to the power of 10, that is 0 to 1023. If it is 12-bit ADC, 2 to the power of 12, that is 0 to 4095, like that. So the sensor value ranges from 0 to 1023 or 0 to 4095, depending upon the ADC is there inside this ESP32. So I think in this case, we have 12-bit ADC. So you can see the ranges from 0 to 4095. So if you keep the sensor inside the wet soil, the value will maximum or minimum will vary. So I have a sensor, I have a glass of water with me. I'll show you now. So this is what it is. All right. So coming back to the connection, these two are connected here. This is a sensor chip, by the way. And you can see that 3 connections. There are 4 pins, but there are 3 connections. Ground to ground, power supply to the power supply. It is working on 3.3 volts. That's okay. One data pin is A0. This is the data pin from where you are going to get the data, and you have to print this data from here, which will show you the output. So VCC to VCC, ground to ground. From here, you have to connect to the data pin. This is a data pin. Okay. Any doubts in the connection? You have to remember these three, and not even this three, just one line. We will write the program. All right. Okay. So now I don't want to use the graphical coding, but however, we'll do that as well. If you are interested in, we can do that also. No. So let me just remove this. Uh, remove this as well, and remove this as well. All right. So that's it. So now integer, I will use sensor, or to be specific,
Soil
soil.
moisture.
We can give anything. To be specific, we can give like this. Or if you're not interested in to give such a big number, just give sensor.
Sensor.
But my suggestion,
Give
always your
a
coding should be so easy that others should understand. So it's better to use something like this. Okay. Soil moisture sensor will make more sense, because in your project, if you have 3, 4 sensor, you
we
don't give
have
a
to
sensor 1, sensor 2, it won't be good. Soil moisture sensor, temperature sensor, humidity sensor. That's how you have to give. So in such way, so let's use. All right, soil moisture sensor. All right. So what is this sensor, by the way? It's an output device. So in mode, what is the sensor?
input. Input.
Sorry, it's input device. I beg your pardon. It's the input device. Input device. All right. So here we go. So soil moisture sensor is an input device. If you want, you can write like this also, not a problem. This is different style of writing the program. So I love this way, but the other one is more popular. All right. So sensor is connected to analog pin, and this is here. It is an input device. Now what we will do, we will use
Analog output.
no digital read. We have to read the value. We are not writing. We have to read what? Sensor value. In previous case, we were writing. For output, you will write. For sensor, I request someone, could you please mute yourself? All right. So here, what you have to do, you are going to read the value. But when you read the value, you have to store that value into one variable. Say integer temp temporary variable. So this is one temporary variable I am using. Okay. So this temporary value, what it will do? It will hold the sensor value. So what this variable will do? What it will do?
Read
Store
the
value. It will show the sensor value. Okay. Now, after this, what I can do? Just print this. So for printing, what I said, serial dot begin. What you have to do? Baud rate configuration we have to do, that is 9600. Oops. 9600. My God, I typing typo again. All right. So 9600. So I had a serial. So now I just want to print this value. So what should I do? As simple as that. Just print. So we'll do one thing. Serial dot print. I will just say here, sensor value is. So this is bad way of writing, but no, bad way of like commenting it, this value, but we have to. So I will just copy paste this. Oh, and then I will write println. So you will see why I'm doing like this. And then the value. So where is the value stored? Here is the value stored. So this is the output. So serial sensor value is colon, and you will get this output, and then you will go to the new line. You can see new line I'm adding here, not here. So what will be your output? It looks something like this. So your value, your output will look something like this. You can see now, it looks something like this. and some value 2, 3, 4, say 5, and then your value will look something like this. Something like this, say 2, 2, 3, 3, something like this. So in this way. So it will be like this, and then it will print the value, and then go to the new line. All right. So that's the intention. All right, so far so good. And but this value will pop up on the screen very, very fast. So therefore, I am interested to add some delay. Otherwise, it will be like bombarding. All right. So seems good. All right. So first, let me compile and see, did I do any mistakes in syntax? If not, then we can connect and see the output. Okay, seems good. So compilation is fine. Okay, so now before to that, so what should I do is I should connect my sensor first of all. So just give me a few seconds because I should connect. I should identify the ground pin in my hardware. So allow me for a second so that I will identify. All right. So this is the ground pin I'm connecting here. So I have connected ground pin and I'm connecting VCC. Okay, the VCC is there. And the last one is the sensor pin. Okay, it's ready to go. All right, so I've connected my sensor pin. So, okay, let me turn on my camera. All right. Over to participants. So you guys can see this is the, so let me just move away from the screen. This is the sensor. This is the device. This is what it is. So now I'm going to load the code and here we go. The code is getting uploaded. All right. And initially, since the sensor is not wet, it will show you the maximum value. And then if I make it wet, it goes to the minimum value. All right, so where I can see the output. So let us plot onto the serial monitor. Oops. Where it is, analog read. Why it is showing 1? So analog, I think I have connected to the wrong pin. Okay. Is my sensor goes bad? No, I think it's powering on properly. Yep, it is. And VPN. Okay, just allow me, just give me a second. Let me check what things went wrong. So let me check the code. So did I do any mistake in the code? Let me check. So sensor pin is connected properly. Okay. And then, okay, so A0 pin is connected properly. And we have, okay, setup is there. Sensor pin mode is input pin, okay, 9600. I have configured to serial.print and serial.println. Seems good. Did I do any mistake? Okay, I beg your pardon. I did a mistake here. It's not analog, it should be analog. I'm sorry. This is analog read, not a digital read. Okay, so let me upload the code. So yeah, there's a mistake. Okay, so let me open it. So you can see the code is getting uploaded. And once the code is done, we will see the output 30, 40, 70, 90% done. All right, so you can see the maximum value. Yeah. So it is having 12-bit ADC. So 2 to the power of 12, that is 4095, because 02409, right? So now you can see I have a glass of water in my hand and I'm trying to put this sensor inside that. And now you can see the values. Hope the values are visible.
Yes, sir. The values are varying.
Yep. Because if I deeper and deeper, the values are getting more change. Now what we can do here is I can go to another option called plotter, and then I can just try even to let me send if it is like working. I
Can we
don't
get a
know.
graph?
Yeah, so it's in the form of a graph. You guys can see the so maybe let's see. I don't know because I used to have long back, but this is little different in UI. I don't know. Okay, not a problem. But maybe you can just configure the graph also. So you can see the graphical values here. If you want the screen values, you can see configure the graph and you can see interpolate or you can do many things here. So that option is also there. Okay, by the way, anyhow, the sensor values are getting displayed. That's what is intended for us first. Okay, so if I remove this from the, then you can see the values are getting 1 second change. Okay, so there is a small assignment for you guys. So the assignment is, can you note down? I don't know how many of you will do it, but make a note. All right, so let me just stop my screen. Okay, so let me give you one small task. Let's see. We give a lot of tasks to the students and let us see whether we will do the task or not. It's good for you. You guys can do this if you are interested in. So the task will be something like this. So I can say it's a homework for tomorrow. Okay, so the task is interface soil moisture sensor and LED to ESP32 conditions. So interface soil moisture sensor and LED to ESP32. Number one, if soil value, soil moisture value basically. So I mean to say here, the soil moisture value is less than 2000, less than 2000, print, print, soil is wet and turn on LED. Second, I'll just copy this and I'll just paste it here. If the soil value is greater than or equal to 2000, soil is dry and turn off LED. Okay. And display, basically display on screen. What screen? Soil is wet and LED is on. This is a message you should display. Okay. So display message on screen, soil is wet and LED is on. Here, what message you will display? Soil is dry and LED is off. This is what. And one more thing, you guys can do this task without hardware also. So there are some websites which you can use to have online tools. You'll get online Arduino, you'll get online sensors. You can write that. You can just browse it if you won't get, I'll help you in that also. Okay, so and let me post this in the group. The task here is all right. Okay, okay, no problem. So I don't find this option. Okay, over to participants. Any questions? So we are sharp 2 minutes late. 2 minutes late. I'm sorry for that. So over to participants. Any question? Okay. Any feedback? Is it good, bad, meeting expectation or not? So depending upon that, tomorrow we'll see. Yeah.
Yes.
Over to participant.
I request all the
Sir,
participants.
If
It's
we
good,
use
sir.
Arduino
Nice.
Uno, the process is same?
If you use Arduino, process
Yeah.
is same.
Yes.
Yes, it's more or less same.
Yeah. Uh, Very much informative session, sir. Thank you. We already just got the ideas and just cleared the doubts, whatever we have. Thank you so very much, sir.
Yeah, you're welcome. And I can say that tomorrow's session will be more beneficial because I
Yeah.
will connect this device to the internet. In the web application, we will pop the data and push the data. So there I will tell you how to configure your ThinkSpeaks. And after that, my suggestion would be, since you guys are at good track, at least try to do few things by your own hands. And I know that you will do some mistakes and you can learn from that mistakes. And when you guide your students, you will be more confident. So, and in fact, if you are interested tomorrow, I can little bit extend, and I'll also tell you how industry we will see the code. So I'll tell you how you guys can code review, how to initiate the code review, how what are the code standards you have to follow. Those some sessions where you feel when you do for your students tomorrow, they feel like okay, my professor knows much about it. So I'll tell you some techniques tomorrow for that also.
Okay, thank you. I just want to ask tomorrow. Actually, I already done the research with Raspberry Pi for the citrus plant classification and detection of disease. So, just I want to know for post PhD from where I got the funding for purchasing the hardwares and just do the research.
Yeah, so maybe, ma'am, we can take up this question offline because this is more specific
Okay,
to
okay,
you.
okay.
Yeah, no problem. That I
Yeah.
can help you. That surely I can help you. But maybe you can talk to Gupta sir and take my contact number, and
Yes.
I will try to help you with that also. No problem.
Okay. Thank you, sir. Definitely.
Yeah, welcome. I'm so sorry, madam. Your voice is breaking.
Sir, can you hear me?
Yep. I can hear you. I can hear you.
Sir, first of all, I thank you very much for the excellent session, sir.
Yeah, welcome, ma'am.
I have a small information about securities in your smart formings.
Actually, this IoT itself having a lot of security challenges, security breaches. So basically, what we do tomorrow, I'll tell you. So
Okay, sir.
basically, what we do is we take a lightweight protocol called MQTT,
Yes,
and
sir. Yes, sir. I know.
yeah, MQTT, and basically below that we'll have a session transport layer called UDP, and
Yes, sir.
below to that we'll have a one physical layer. So we'll add a security at each level. That's called TSL layer. And also
Yes,
what
sir.
we do, there is a concept called pen test. That's called penetration testing. So any
Okay.
device which is IoT certified should undergo penetration testing from industry, and
Okay.
therefore then only they will have that product into the market. So that penetration testing will have a basically full load testing. We'll try to bombard lot of data to that. That's called DOS attack. Example is called denial of service attack, and we'll try to do lot of such kind of attacks on our devices and see the performance. If it is well and good, then we'll release it to the market. Otherwise, the certification will go free. So basically, any
Okay.
product which I'm working on will have a minimum life of 40 years. Means a device which we are coding in industry will run 24 by 7 for 40 years without any problem. So that is the level of code generally we do. And there's a big process for that. And maybe Gupta sir, if they are interested, you guys are in, then maybe not be tomorrow, but is that's a it's a complete different session. I will take one
Okay.
session where I'll tell you from coding till deployment, what is the procedure is followed in the industry.
Okay, sir. Thank you, sir.
Welcome. Any other question? So I'll take up two more, then we are good to go. Any one or two questions over to participants. All right, then thank you so much for attending the session. Let's meet tomorrow. Have a great day, everyone. Bye-bye.
Thank you, sir. Thank you very much, Vinod, sir.
Thank you.
Thank you. It's wonderful sessions. Thank you, sir. Good night. So, guys, have a good night. Thank you. Thank you very much. So, please, all of you leave.